Okay, now I'd like to do a little bit of review of adding and subtracting fractions that have like denominators, okay? So in a bit we're going to do this with some rational expressions, but let's just remind ourselves what the deal is when we're adding and subtracting fractions. So when we're adding and subtracting fractions, we have to have a common denominator, right? And if the common denominator already exists, then to add or subtract those fractions, we just need to add or subtract the numerators, right? So if you have a over c plus b over c, that's equal to a plus b over c, right? Same with the subtraction, right? A minus b over c. Okay, so just like for example, let's say I had 2/5 plus 3/5, right? That would be equal to 5/5, which happens to be 1, right? If we were to subtract, maybe we want to have 5/8 minus 3/8, right? 5 minus 3 is 2, so we end up with 2/8, and that reduces to 1/4, right? Okay, so just a little refresher on how does this work with fractions. So now I'd like to try a few examples of adding and subtracting rational expressions where we have some variables involved when the denominators are the same. Okay, so our directions here say add or subtract the rational expressions to a single rational expression and then simplify. If applicable, state the restricted domain. So let's try this first example. We have y plus 2 over y minus 2 plus y minus 6 over y minus 2. So in this instance, we have a common denominator already, right? So I just need to add the numerators, which is going to be y plus 2 plus y minus 6 all over y minus 2, right? Now we need to combine like terms in the numerator. So y and y is 2y. 2 minus 6 is minus 4. All over y minus 2. Okay, now I notice once we get it into just a single fraction, I notice that I can factor the numerator. So I'm going to pull a 2 out, so I'll have 2 times the quantity y minus 2. And notice what happens there. We have a factor of y minus 2 that can go away. So this simplifies to 2, but we have to say that y can't be 2, right? Because we just canceled that factor of y minus 2. 2 would make the denominator 0. So in this next example, I have 1 over t squared minus 7t plus 12 minus t minus 2 over t squared minus 7t plus 12. Okay, so we have a common denominator of t squared minus 7t plus 12, right? So in subtracting the numerators there, I'm going to have 1 minus t minus 2. Okay, I'm writing it this way because I want you to see that we have to subtract that entire numerator, right? And all of this is going to be over t squared minus 7t plus 12, right? Okay, so in the numerator, I'm going to distribute the negative through. 1 minus t plus 2 all over t squared minus 7t plus 12. Now in the numerator, I'm going to have 3 minus t. And I'm curious about the denominator. If it factors, maybe we can simplify it a little bit further. So factors of 12 that add to negative 7, that would be negative 4 and negative 3, right? T minus 3 times t minus 4. Okay, now it looks like we can't cancel things, but remember we've got the 3 minus t versus t minus 3. So I'm going to factor a negative out of the numerator there. Right, so I have a negative times the quantity negative 3 plus t all over t minus 3 times t minus 4. Okay, now negative 3 plus t and t minus 3 is the same thing, right? So I could just rearrange those terms, but I know they're the same. Okay, so then I end up with negative 1 over t minus 4, right? And make sure that you say that t can't be 3, right? Because we canceled out that factor of t minus 3. Great, so hopefully you're getting the feel for this just in terms of the addition and subtraction. Once you actually get a single fraction, then you're just simplifying the rational expression from there.